I think we're up and running here. Folks on the live chat can let me know if they can see and hear me okay. We'll get going here at the top of the hour. Thanks for joining me. And we got several things to look at before we get to some Q&A here in a bit. How's everyone doing? It's been a while since I did one of these. Great. J. Scott McLean, I think you're always the first one in on the 5x5, so appreciate that. Awesome. Peter from Dayton, Ohio is here. Great. Brian E. Awesome. Technology's working. The webcam's working. Hopefully the sound and the video's working okay too. Yeah, we'll just do a little bit of chit chat here for a bit, and then once we get to the top of the hour, I will briefly go over a few announcements, get right to the Kilauea update, and then come to you, good folks, for some Q&A. I know some of you are in Europe and are burning the midnight oil to be here, so I appreciate you. This was just the best window of time that worked for me. I liked it a little later in the day. Helps with Kilauea because they're 4 hours behind me, and so it allows me to get at least a little bit of that day's data and information. If I do it in the morning for me, which might work best for folks in Europe, it's still quite early pre-dawn hours in Hawaii, and those folks, there's not as much data, imagery, and stuff to get. So the Kilauea updates definitely, in terms of doing them as a live stream, it definitely helps to do these in the afternoon. So awesome, people are filing in, excellent. Iceland is here, Scotland, Billings, Montana, North Carolina, Vancouver, Canada. Meg says it's great to be here. We're glad you're here, Meg. In Maine, awesome. Toronto, Tim is here from Toronto, excellent. Jane in Texas, another Jane in Longmeadow, Massachusetts. Jeffrey in central New York State. Joe from the island of Jersey. Dustin from Idaho, Rill from Myrtle Beach. We just spent time there in June as a family. It was actually great. I had never been to South Carolina before, and Myrtle Beach was really fun. We had a great time there. The mini golf capital of the world. I did not know that until I spent a week in Myrtle Beach. And yes, we played mini golf at 2 different places. I love mini golf. I don't really golf, but I like mini golf. Let's see. Kevin from the UK. I'm going to miss some folks, so I apologize. Anthony from Herefordshire, UK. Robin from Sussex. So yeah, some folks in England and UK and Europe just staying up late for us. Appreciate it. Julie from Maine. That's two from Maine. Lori from Minnesota. Mabodi from Italy. Awesome. Stephanie from Austin. I think that's the Stephanie I know that I went to Iceland with. Excellent. Sandrine, our good friend from France. Yeah, Sandrine, if you get tired, you can catch it on the replay. I apologize. Yeah, there's no great time. I guess the good news is we have such a worldwide community that we're allowed, that's the good news. The bad news is there's no perfect time that's going to thread the needle for everyone, I suppose. Safi from Stirlingshire, Scotland. Watching with their bedtime cocoa. Excellent. Christian from Austria. Vincent from Hawaii, Makaha. Aloha, my friend. Tanya from Stafford, Texas. Gabrielle's also in France. Yeah, Europe's representing. There's people who are staying up late. Excellent. Elodie from Western Washington. Bunny Rabbit from Indiana. Egg9 from Ireland. Loves my random road cuts and Geology 101 videos. Thank you. Those are fun. I love doing those. I got more in the hopper, so they will keep coming your way moving forward. Oslo, Norway. Is that Xwick? Yeah, some of you have cool little handles. I wish I had a cool YouTube handle. In hindsight, I might have changed the channel name to something other than my name, but didn't know how this would grow, and it grew in a great way. Stormy from just says good afternoon. Stormy 7572. David from Surrey, England. Mary's in Southern California. Geology Grandma's in Orlando. Robbie Robin says hello. Vinny from New York. Carola from Austria. FSW is the dog from Wales. I've also been to Wales. Pretty cool place. Oh, and then the live chat just scrolled down on me there. We'll do a couple more minutes of shout outs, friends, and then we'll get started. Thanks for staying up or chiming in, whatever the time may be, wherever you are. Linda from New Zealand. Wow, what time is it in New Zealand? It's obviously Friday. I guess it's probably morning, right, in New Zealand? Nicole from Germany. Leroy from Texas. Mark from Florida. Susan from Australia. Wow, we got quite the group here. Hermine from the Netherlands. DJ Mini 2 from Canada. Mopar Toolman from Oregon. Sorry if I'm butchering these names and places, friends. Sue from Texas. Lee from Chicago. Yeah, make sure you hit the like. As always, thank you so much to our good moderators. We have Susan Helmer here and Mandy Joe or Amanda Joe that are monitoring the live chat. They'll be aggregating all the questions and stuff. Neela Dandy. I hope I didn't butcher your name. I tried. Marty Herford from Michigan. Kylie from Melbourne. Steve from Swan Falls. We're almost out of time, so I'm trying to get all these in. Liquid Sun from Florida. Mr. Salty from Northeast South Carolina. Great. Lots of great folks here. Hi, Stephanie. Hope you're doing well. Chuck from Alabama. Excellent. Yeah, 122,000 subscribers. Pfft. Who would have thought? Especially my wife would have been shocked to learn that many people in the world would be interested in geology with me. Mallorca. Iris is in Mallorca. Mary's in Safford, Arizona. Greg, who I've met from Tennessee, is here. He's in Washington traveling. He usually does that this time of year. Great. So yeah, we'll get started here in a second. Great to see you all. Hi, Marion from Salt Lake City. Dan made it just in time. Awesome. Okay, so yeah, one more minute, we'll get started. The game plan here, team, is to do a few announcements at the beginning, 5-6 minutes if you will. We'll get right to the Kilauea update, some fun things happening in Hawaii. And then when we wrap that up, don't know how long that'll take, I'd say maybe 20-ish minutes. Then we'll come to you for question and answer. Amanda Joe's actually sent me some. Once we announced the live stream, she did receive some questions, I guess by email. I didn't ask, but she's already sent me those. So I'll start with those, and then we'll go to your questions. So make sure you follow the prompts from our moderators about submitting questions. I'll try to answer them as best I can. I am not an expert on everything. So, okay, it is the top of the hour. Welcome. Thanks for joining me, and aloha. I am Geology Professor Shawn Willsey. Welcome to this live stream event. Today is Thursday, September 19th, 3 p.m. here Mountain Time. That would make it 11 a.m. over in Hawaii. And we're diverting a little bit from what we've been discussing the last few months. Iceland's kind of been at the forefront of many of the things I've been doing with the eruptions we've been seeing there over the past year or so, I suppose. And Kilauea has been kind of lurking in the background. There's been a few little events. There was a small eruption on the southwest rift zone within the past year, some activity at the summit, some intrusions and earthquakes that we've been seeing in the East Rift Zone. And this week, that activity has culminated in an eruption that is still ongoing. So we're going to discuss that a little bit. I'll provide as much insight as I can. As always, remember, this is a learning community, so we learn from each other. And we want to encourage that just curiosity and positivity that makes this such a great place to come. So thanks for joining me no matter what the time, no matter where you are. So a couple quick announcements here. So one thing of interest that happened over the weekend, and maybe the only one that'll find this exciting is me, but I wasn't really looking for it, but over the weekend I was checking the page for a couple of things, and the YouTube channel had reached 500 videos, which I thought was kind of a cool milestone. So there you go. go team, hooray us, confetti, you know, celebrate as you will, but it was kind of a cool milestone to achieve that. So this is a credit not to me, but to all of us, because without the viewers and the people who find these interesting and educational, this would have crash landed at 5 videos like 4 years ago or something like that. So shout out to everyone who's helped me build this up. Thank you very much. So fun little milestone there. Couple quick other announcements. I do have a few field trips coming up next week, and I just want to make one last pitch for these field trips. If you are available, these are in northern Utah in the Salt Lake City area. Big international airport right there. Fall in the Wasatch Mountains is magical. The leaves change colors, the aspens and the oak trees, and it is just glorious. And so there are 3 field trips planned for Friday, Saturday, Sunday, the 27th to the 29th. They run from about 9 a.m. to 5 p.m. each day. We meet in a central location each day, and then we organize a carpool, and then we kind of travel around looking at some great geology along the way. So that is all on my website, willseygeology.com, that Amanda Joe put together. So if you want to and are available, this is where you can go. And there's still space available. They are sort of filling slowly, but there is space available in these field trips if you can make it. You don't need to sign up for all 3. You can sort of, it's a menu option. You can sign up for whatever works for you. A day in Little Cottonwood Canyon, a day out at Antelope Island State Park in the middle of the Great Salt Lake, and then the final day is sort of a transect from Ogden on the I guess the west side of the Wasatch Mountains, moving to the east and cutting through this ancient mountain building event, the Severe Orogeny. So we'll go from the guts of the mountains to the basin deposits there near Echo Canyon. And so those are those 3 field trips there. The other field trips are in October, the 11th, 12th, and 13th of October. Those are in southern Idaho. And then there's 2 field trip dates in early November, the 8th and the 9th, that you can choose from as well. So there's a little pitch for those. One other thing on the website, we have had some requests that I've heard for merchandise and things that people might want to give for Christmas gifts and that. I am working with a graphic designer on getting some logos and some designs going. So that is in the works, and I hope to have that done within the next month or so. I might put those out to you good folks maybe as a poll to see which logos or graphics they put together, which ones you like the most. This is not my skill set, so this has been very, I wouldn't say stressful, but difficult. You know, my brain is scientifically focused. I don't think well in art. I don't see colors well, and so, but then at the same time, when I see something I know I don't like or that doesn't fit, I kind of know it. And so, so anyway, look for something on that front sometime soon. And then the other thing you might notice about the channel is I've also been educated by my wife and some other folks about the fine art of designing thumbnails for my videos. If you look at some of the older ones, there's a lot of words. I tend to put the words right on top of the image. And I've been told by people in the know that that's not a good way to attract new viewers and get people to watch your videos. So I promise to never be clickbaity. If I put some text on the slide, which it'll almost always have, it will always be factual. So I'll never say Kilauea erupts if there's not an eruption. But I am going to try to trim down the amount of words on each thumbnail, try to make them enticing. It's the game you have to play. So I'm trying not to sell out completely and be like, you know, the clickbait YouTuber, because I don't want to do that. I have integrity, I have a reputation, and I want to maintain that. And so, but at the same time, I think there's some small things I could do on my end to make the videos more enticing to people who might not be part of our community. So we might be able to get some other folks in that would like to learn with us otherwise. So anyway, that's good enough for now. I think that's all I wanted to cover on the front end. So let's go ahead and jump to Kilauea, and let's just jump right to the webcam, because this is there's actually a fantastic thing happening right now in Kilauea, and it's been going on, I think, since last night or so, at least for the better part of today and partly into the evening. But what you're looking at there may be a little bit difficult to tell because we have full lighting with the sun out there. It's 10:30 or so. Let's actually refresh this and see what we get. Okay, so it's 10. The last image here is 10:43. So the USGS did get out closer to the eruption site and put up a webcam. I know it's not super close, and let's also be careful that we don't compare the coverage of this eruption to Iceland, and start nitpicking and complaining about the lack of webcam coverage. I think we could get into the weeds about why there's such a discrepancy there. Kilauea is a huge volcano. It's vast. It's in a national park, most of it. It's in a rainforest. It's not open ground. There in places it's heavily forested, and there's lots of places where it has and can erupt. And so that's maybe at least one reason why, there's not like a webcam, every quarter mile or something ready to go. But they did get one deployed out there. And what you're seeing right there in the image is you can see the plume of gas there in the middle of the photo. And you might even see a little bit of red right here. So there's some fire fountaining right here. So that's our fissure, the active fissure right now. That's the vent, the current vent. And that is feeding a lava flow that is heading downhill, pouring over the rim of Nepal crater, this big pit right here, and then falling down into the crater here. So there's a lava fall, if you will. I guess, I don't know if that's an actual word, but we just made it up. There's a cascade of lava vertically falling off the cliff edge there down to the bottom of the crater floor. And I think it's about 150, 160 feet, about 40 to 50 meters in height. Those are just some estimates I put together. So pretty spectacular. If we kind of come down, let's go back one and come down here, you'll see a bit of a time lapse that shows it overnight. So there you can see the glow. This is going into the early morning hours today. And so here it is right now. Or no, excuse me, this is yesterday afternoon. Then it starts flowing over the rim. Then it gets dark. Then it glows beautifully. You can see some of the lava out here on the crater floor. And then it goes up through till today and about now, and then it loops back. Now it's already back to yesterday. So yeah, I'll put these on the video description. If you want to watch these, you can. Yeah, I mean, if we've been, let's be honest though, friends, like, is this a satisfying view of what's happening? No. Do we wish we had ESAC and other people with drones there to get us great footage? Of course we do. But it's a national park. There's rules and regulations with the drones. And I mean, we were really spoiled with Iceland, if we're really being honest, right? Like that, I've been watching volcanoes a while now. I've never seen a volcanic eruption that well documented from multiple angles as what we saw over the last year on the Reykjanes Peninsula. So, if that's the gold standard by which we measure all eruptions, be ready to be disappointed from time to time. But nonetheless, I think there's some things we can see here, and the USGS does a good job of providing information to the public as best they can. Unlike Iceland, there's not a lot of bunch of news agencies with webcams able to mount their webcam on the closest hill, and so there's some, I don't want to call it red tape, but there's some difficulties inherent to the terrain, the location, and the property that makes it difficult for us to see this as readily as we might otherwise. And if the eruption goes on, I have full confidence that if this eruption persists, we will get some better images coming out of the USGS. So there, I said it. Here is another webcam image from Pu'uo'o. So this is looking to the west. This is a little less satisfying, but it does show you the plume. So we're looking from the west side of Pu'uo'o to the west, and towards Nepal crater. The little dome a little bit off to the right there, that's Mauna Ulu. So that's a shield volcano that erupted in the late 60s and early 70s. It created that shield during that eruption. So we do have some other little images there. Here's the time lapse for this one. And mainly just showing, at night it shows some of the glow. When it kind of goes away, those are periods where it kind of like waxed and waned a little bit in activity. Or there was clouds maybe obscuring the view a little bit as well. They've done a great job of providing photos and videos for each day of the eruption. So I know today is September 19th, but they haven't put together, because it's still quite early. It's before noon in Hawaii. So they have not compiled all the photos and videos for today. So this is from yesterday, but here's some of the great images they took on a helicopter overflight Let's see who, I do know a couple of the folks there. Oh, this is Matt Patrick. I've met him before. So this is looking, the rim of Napao crater sits right here. This is the lava flowing, well, the older lava that was kind of flowing off the edge. That's actually resumed since they took this. So this was from yesterday morning. And you could see yesterday morning that the activity was down in the crater floor. That's since changed, and the crater floor now does not have any of the active vents. The active vents are now back up here along the rim, and I'll kind of get to that. But I just wanted to show you some of the photos they took. The lava flow itself, kind of a shelly, slabby Pahoehoe flow, it looks like here, transitioning a little bit maybe into an A'a flow. Little fountain here. This is all from the crater floor. Another image there, little lava pond next to this vent. Old section of the fissure here. You can see how blue some of that sulfuric gases coming out of the vents there. And this is mostly with overflights. Here's the latest thermal map we have. Make that a little bit bigger for you. So the initial eruptions were back over here, back on Sunday and Monday. Then it moved to the east and started flowing from fissures in this area and some in the crater. And that's when this map was made, was yesterday. But between yesterday and today, those fissures in the crater have died down, and the fissures above it have resumed, and that's why we're seeing the fountaining up here and then the lava flowing over the rim of the crater and starting to partially fill Napao crater. So, and again, this is all in Hawaii Volcanoes National Park. It's all in an area that's very remote. There's a trail that goes in there. To hike into this place, it would probably be, oh, how far is it out to Napao crater? Maybe 4 miles, 6 kilometers, something like that from the trailhead, which is of course closed. But it's in a pretty rugged area, not very readily accessible. Again, you know, this is one reason why the webcams aren't just sitting there ready for us. There's no roadways into here. It's a pretty remote area. Here's the same view with the map. So this is a bigger view. Here's the Chain of Craters Road in the bottom left corner. So this is the road that goes from the Kilauea summit area in the national park down past some of these pit craters here, these big depressions, and then this road takes you down to the coast. But there's a little pull out here, and then this is the trailhead right here you can park at. I have a video I did of this little section of this fissure right here, which was part of the Mauna Ulu eruptions from 69 to 74. In the past, we've taken students and hiked up to the summit of Mauna Ulu and gone to the top of Pu'uhuluhulu. And then you can take the trail beyond that out here past Makauapuhi crater, and then out here all the way out to Napao crater right here. So here's inset box here. And so what you can see here is the the fissure that was eruptive. This is for the 18th. So these two little pads of lava died down, those fissure vents, and then the active one picked up yesterday was here. Then it was active in the crater, and now it's back to this location. So it's the active vents are kind of dancing around a little bit, but roughly in this stretch here is where we're seeing most of the eruptions taking place. Couple of folks did post some great photos on Facebook. So here is a nice photo of the lava falls. So looking out to the west, I suppose. Mauna Ulu, I think, is there in the background. And another one just probably a few minutes later when it's a little bit darker, showing the lava, the vent right here, and then cascading over the rim right there. And then someone else posted some aerial photos from a plane, I think, maybe a helicopter. Here's Napao crater here in the bottom left. And you can see where the vents are here, these kind of older vents that are not producing as much lava. The big one that's producing the lava here is feeding this flow that travels a short distance and then goes into the crater, and it's partially filling a portion of this crater. So from a safety perspective and a public perspective, great location, remote part of the national park. There's a huge pit for a lot of lava to pour into and be confined to. None of this lava looks at this time to be approaching any roadways or infrastructure, no threat to human safety or property. I guess here's another view right here of the same sort of thing from a different view, more oblique view there. Okay, and then I did put this link under the video description as well. So if you're a little confused, the timeline, because it has been a bit of a confusing or complicated, that's a better word, or involved eruptive sequence. And so they've got a nice timeline right here of exactly what takes place. And if you look at some of my last updates, those were kind of in the moment. And that first one I did this past Monday, we weren't even sure if there was an eruption because it was still early and the weather was kind of socked in. Now, of course, we know that that eruption did begin on early on or late Sunday night. So you can kind of read through the description here. I won't read this all to you, but it kind of tells you what was taking place for each day of the eruption. Undoubtedly, they'll add another bullet point later today when they kind of summarize today's activity as well. One cool thing I found was, we can check out this photo. I think we've seen that one before. Oh, this one's pretty nice because this is looking again. We saw this one. This is the rim of the crater, but this one shows looking to the east. You can see Pu'uo'o, the big vent. So this volcano in the distance here, this was the primary vent from 1983 through 2018. This was Kilauea's favored and main vent for lava, this big volcanic cone shield volcano here, and that sent vast quantities of lava down to the coastline on the southeast coast of the Big Island. One cool thing I found was that the GOES satellite actually picked up the eruptions. And so if you look at the little red dot right there on the volcano, let's do, let's just find the best one here. But the point is they picked up the eruption with their satellite imagery. Let's see if we can find, so hopefully you guys can see that. It's so small and faint. There we go. So see the red dot right there? So that is this wavelength spectrum picking up the glow from the eruption on the Big Island, which I thought was pretty cool. Just kind of a fun little bit of data there that they can use that data sometimes to verify that there actually was some sort of eruption. Let's pick the right. Okay, so the update, they haven't done the update for today. Oh, they have. Oh, cool. All right, we'll do this in real time. Last I checked, right before the live stream, it was yesterday's update. So let's go ahead and do this together because I have not read this. So today's update, hot off the press, 10:24 a.m. So that was within the past hour. Kilauea volcano continues to erupt in the park from a new vent that's just west of Napao crater. This is the fourth vent system of the eruption, and it began rapidly creating lava cascades, or lava falls, I guess it is a word, that poured over the western cliffs of Napao crater. The activity continued overnight, and the lava falls were visible on the S2 webcam this morning. So that's that first webcam I showed you at the beginning here. The eruption is occurring within a closed and remote area of the park. No immediate threats. Let's see what else. Summit observations, nothing happening at the summit except deflation. I'll talk about that later. Rift zone observations, because this is all happening in the east rift zone of Kilauea. So the fissure remained active overnight, continues to feed lava cascades, which go down into the crater and have covered approximately 250,000 square meters, or 300,000 square yards, or a third of the crater floor since the eruption began yesterday. The rate of coverage indicates lava is erupting at roughly 5 to 15 cubic meters per second, which is about 6 to 16 cubic yards per second. At the time of this notice, fountaining remained strong as observed on the S2 cam. So we saw that back here. You can still see some of the fountaining kind of squirting up there just beyond the trees, even from that big distance. And let's see, shallow earthquakes remain low in the Middle East Rift Zone. We'll get to those in a second. So there's not a lot of earthquake activity. Tilt meters continue to show no significant changes. So apparently there's a pretty constant inflow from the summit reservoir into the Middle East Rift Zone. Nothing's really significantly inflating or deflating much. right now, but we have seen some big movements in the past. They talk about this large displacement from one station just downslope of Mako'opuhi crater, which experienced, and this is staggering really to me, at 1.8 feet or 54 centimeters of south-southwest motion since September 14th. So basically in 5 days, it moved that much. That shows you how much, how influential that magma intrusion was in moving the surface a little bit. Combinations and the displacements and tilts suggest that much of the deformation is a result of magma entering a storage region several kilometers below the surface. And this is what's interesting here. Analysis. The ongoing Middle East Rift Zone eruption is currently in its fourth phase of vent opening and lava production. Each eruption has increased in volume, with the current eruption being the largest to date. Multi-day fissure eruptions are not unusual, and current eruptive activity appears to be linked to supply of magma from the summit. So it's interesting because it's behaving somewhat the opposite of what we saw in Iceland, where Iceland fissures started with a bang. The initial phase of the eruption was the largest volume of lava that was erupted, and then they tended, most of the time, tended to dwindle down over the next few days. This one started out with something that we weren't even sure was much of an eruption, found out it was, but it only just, it poured out a very small minor amount of lava. Then the second phase was a little bigger, the third one on the crater floor, and now we're on this fourth phase, which is bigger still. Doesn't mean necessarily that that trend will continue, but it is interesting to compare this eruptive activity to what we've seen in Iceland. And then they go through the typical hazard update with VOG and such, which I'll show you a little bit of that here in a bit. So very cool, new, and there's some nice other resources in here. So if you go to the Kilauea update, you can find a lot of these sites that I'm taking you to here. One fun thing you can play with, and this is on the video description as well, but there is a really great, let's make this big here, site. So here's Kilauea's summit. Here's the East Rift Zone coming down this way. And right now I have selected the recent lava flow map. So you can actually see they're continuing to update this lava flow map, which shows this recent fissure and the partial filling of Nepal crater. But what you can do over here is you can, we could take that off, let's say, and then what you do is start adding old lava flows. So you could actually go through this sort of, if you wanted to, for a fun Friday night, go through these iteratively. So start with the 1778 to 1839 eruptions, which are kind of off the map on the Southwest Rift Zone, 1840 to 1868. So we saw eruptions in this region in the mid-1800s. 1869 to 1924, mainly it's back up to the summit, confined up here. 1925 to 1950, I think that was back in the Southwest Rift Zone. Yeah, back over that way. 1951 to 1982. So this is where the Middle East Rift Zone was quite active, and a lot of the volcanic features we see there today, including Mauna Ulu, formed. So this would be 50s to 82. That's about a 29 or so year period. Sent lava flows all the way down to the coast. Built this big shield volcano here, among other things. And then when we add 1983 to 2018, here comes the Pu'uo'o eruptions, which are these massive ones over here, including some of which filled in partially Nepal crater. So if we just take off all the old ones there, this is 1983 to 2018, and we did have some eruptions, some small little fissures to the west of Pu'uo'o that did impact this area. So pretty interesting to see what this part of the Middle East Rift Zone has done. It hasn't done much since, well, 2018 for sure, but these flows here are more like 1997. And now we're seeing this activity over here. So it'll be interesting to see moving forward how this kind of all plays out. And we know that Kilauea can kind of bounce around between, one area being dominantly active, the Southwest Rift Zone, the summit, the East Rift Zone. But it's pretty interesting that just in the last few years, we've seen activity in all three places. We had that small eruption here on the Southwest Rift Zone, some activity at the summit, and now we're picking up on the Middle East Rift Zone, where we haven't seen anything since 2018, but really in this section, we haven't seen anything since 1974, or so. So it's been a good 50 years since we've seen activity in this part of the rift zone. So this is a fun little map. You can also go in here and find out where the instruments are. So you can add the GPS stations, the tilt meters. You can go in and add the earthquakes if you want to. So we can pop in earthquakes over the past. You can do that hourly, by days. If we add the last 2 weeks of earthquakes, we're going to get a bunch. Yep. So there's all the earthquakes that led up to this eruption. So nice little interface here that they put together that you can kind of play with. So that'll be under the video description as well. If we look at the monitoring data, these earthquakes, most of these earthquakes you're seeing here, let me make that a little bit bigger. This is the past week, and so most of these are happening from last Thursday up through Sunday when the eruption began in earnest. And you can see that the location of these is mainly, some of the Kilauea is here. This is the Middle East Rift Zone right in here. The Whole East Rift Zone trending down to the Lower East Rift Zone down here. The typical deep Pahala quakes that we believe are right. These deeper quakes are related to the hot spots, that magma's coming up, and then it's deflected over to the northeast a little bit and comes out here at Kilauea. But there you can see a cross section, the deep Pahala quakes over the past week, and then all these quakes here right in the upper and middle East Rift zones. None really taking place in the lower East Rift Zone, which is good because we have property and homes down there. If we look at the earthquakes per day, so this is each day's earthquakes, you can see them ramping up, the 13th, the 14th, and then the 15th, everything kind of reaching this crescendo here. That's when the eruption really began in full force. And then the earthquakes dropping down considerably. And we don't have as many earthquakes now because the magma has a clear path, or multiple pathways in this case, to the surface through those vents. So we don't expect those earthquakes to really ramp back up unless we start seeing magma migrating to some other area. If the magma stays where it is in this area, we'd expect these to stay pretty low. If you look at earthquakes over the past week, plotted up by depth, you can see quite a few earthquakes here. A little bit of a lull on the 14th, things slowed down a little bit, and then boom, that big 4.3 earthquake that was sort of the first domino to fall, and then all the earthquakes that came after that were related to the magma working its way to the surface and producing the eruption. If you look beyond about the 17th or so, you can see just very few quakes there. And then the last thing here on the monitoring data is this is a tilt meter up near the summit of Kilauea. And so you can see that it's pretty steady. So every time we see this go up, that would be inflation. Think of it like a level, like a carpenter's level. So it's either tilted up or it could be tilted down. So the spike right here is the big earthquake on later on the September 14th. That's the 4.3 earthquake, that little spike right there. And that was the initiation of the magma, some of the magma moving out of the summit reservoir down into the Middle East Rift Zone. And that's why you see right after that earthquake, a little bit of a lag time, but then there's a steady drop in the tilt there. So a deflationary cycle as we see the magma moving from the summit into the Middle East Rift Zone. Then it kind of stabilizes, but then it starts dropping a little bit more, and it seems to still be dropping, not quite as steep as it was here, but what that tells us is there's continual magma movement from the summit reservoir into the Middle East Rift Zone. And so I would expect the eruption to go on until we see maybe this level out. And that would just be one data signal, but that would be one signal to look for, is this thing flattening out with no more of a downward turn. So we'll have to see if that bears itself out in the days to come. VOG over the island, you can see the forecast model here. So trade winds coming from the northeast is going to carry some of those gases to the southwest. Towns like Pahala, the South Point area, maybe Ocean View Estates on the southwest rift of Mauna Loa, those places might see their air quality worsen a little bit. But the eruption's fairly small. It's not the biggest plume going, but that's the dispersion of SO2 that's modeled based on the winds. And then finally, before we get to your questions, I thought it would be worthwhile to come back to this handy dandy cross section that the USGS put together a number of years ago. I guess it's not that long ago, January 11th, so just earlier this year. Um, of course, this is, not 100% accurate, but it just gives you a conceptual model of exactly what takes place beneath Kilauea. So there's a deeper magma source, the hotspot that brings the magma up towards the surface that accumulates here near in the summit caldera area here. And let me go back one. I think they actually give, oh, here we go. SC marks South Caldera Reservoir. I just wanted to see what their notations were here. H is Halema Uma'u, the pit at the southwest zone of Kilauea. So you can see that the magma that comes up feeds both the summit caldera region. It at times can move off to the southwest rift zone and feed flank eruptions along the rift zone there. And in this case, it can move off to the east and feed eruptions in the east rift zone. And there's Napao crater. That's the crater that's being filled with the adjacent vent that's taking place right now. And so it's, I haven't seen, I would be interested in talking to a USGS volcanologist, and maybe I could set something up, is finding out exactly how this plumbing system works, because sometimes it's moving up towards the summit, sometimes it moves over into the southwest rift zone and shuts that down. Sometimes it erupts from two places at once, simultaneously. In this case, what we're seeing is southwest rift zone's quiet, summit is quiet, and the magma's preferred path is coming down here to the east rift zone. And maybe a possible explanation for this would be to consider that the east-west rift zone partially exists because this whole side of the volcano's flank is sliding towards the ocean. There's no support here. This is just a big pile of pillow lavas and rubble on the seafloor. You've got the wave action eroding the coastline. And so as this whole flank here moves towards the ocean, towards the southeast here, that can create openings, spaces in the rocks, and that can create new pathways for the magma to move. So that's something I've always thought makes sense in my mind. I don't know if it's accurate, but it's at least an idea that these rift zones can sometimes be the preferred pathways for the magma to move through when we have this either, could be earthquakes that move and then create the space. Maybe that was the story of the 4.3 earthquake, or it could be what we call aseismic creep. Basically, the whole flank of the volcano just slowly and without earthquakes moving and sort of sagging towards the coast, and that opens up fractures and cracks in the rock that allow the magma to move through it. So maybe I'll see. I mean, they're probably super busy. I don't know if anyone have time, but I do have some contacts there at the USGS, and so I'm going to write myself a note right now and see if we can get one of them to give us an hour or so and either do live stream with us or maybe an interview. I've got two names in mind that might be a good idea. So yeah, and some of you, I just checked the live chat. Yeah, these movements towards the ocean can be slow, and there's evidence that many of them are kind of slow, but there is also the threat that these can occur quickly and collapse suddenly and create huge debris fields like you see here off the coast of Oahu. All this lumpy ground off the coast was a section of the northeast side of Oahu that failed catastrophically, moved, literally hundreds of miles, however far this is. Let's see how far that is, shall we? We'll do it in miles and then kilometers. Yeah, about 100 miles, 150 kilometers out into the ocean. And if it moves suddenly, it displaces a huge amount of water and creates a massive tsunami. And so there is evidence on the Hawaiian Islands of those types of collapses. We don't have any evidence whatsoever that that's about to happen anywhere on the Big Island, but it is something to mention because it is part of the island's history and yeah, the geologic history there. So but because it's fantastic and exciting, we'll tend to focus on that. But these slow episodic movements, which are probably more the norm than the big movements would. Yeah, and you can actually see that the rift zone doesn't end at the coast. You can see it continuing out under the ocean. It probably erupts out here from time to time, but because it's underneath, thousands of feet of water, and it doesn't affect us, and we can't even really monitor it unless there's seismic activity there, it goes largely unnoticed and unchecked. But these rift zones are much bigger than what we might just think otherwise. They extend. Same thing with the southwest rift zone off Mauna Loa. I can't remember if it's this ridge or this ridge, but one of those two. You can see it kind of extend. But the Kilauea's east rift zone is very well displayed right here. So, alrighty. I think I covered everything I wanted to, and I'm happy to tackle any questions you have. Let me start with the questions that Amanda Jo collected from some viewers earlier. So let me just start with these. So let me just make this smaller. Sorry, friends. Okay, this will work. Yeah, then I can still see the live chat. So hopefully that makes sense, the update I put together for you here. Okay, first question, and she didn't put who these are from, so if I'm not giving these folks credit, apologize, but I'm assuming you're just happy if your question gets addressed. So why are the fish eruptions in Hawaii longer lasting than the fish eruptions in Iceland? I would argue that they're generally not. I don't think we can base the 6 or so eruptions over the past year on the Reykjanes Peninsula as, the typical behavior in Iceland. So if you're talking about the actual time of a given eruption from start to finish, or are you talking about, episodes that last maybe years and decades or so? I think there's a good case if we dig into the data that's not the case. Hawaii sometimes has these little tiny eruptions that don't last very long. And, we can see that with this thing here. If we kind of go to some of the past lava flows, let's take out the earthquakes and, throw in some of these old lava flows. I think you'll see there's plenty of these that are kind of small hiccups. Even just this year, we had this one over here that was fairly small and didn't last very long. So I think that's more a perception than a reality. Next question, will Hawaii and Iceland ever be all underwater again? Well, as far as I know, they never were. Once they became active, once those hotspots became established, which we don't understand exactly how that was generated, and they started erupting so much lava that it built up above the ocean and formed land. That's what's keeping those two islands, one in the Atlantic and one in the Pacific, well above water. Is the continual outpouring of lava continues to build the land up. So I don't think they'll be underwater anytime soon. Next question, does Hawaii have a hotspot mantle plume? If so, is it the same as seen in Iceland? Yeah, they're both driven by hotspots, but Iceland has the added complexity of also being a divergent plate boundary. So the hotspot has actually taken advantage of that. Well, it's actually the opposite. The divergent boundary has sometimes jumped over and matched where the hotspot is because it's a weak zone. So it's an efficient way to break apart those two tectonic plates. Hawaii, however, is just a hotspot, but they are both hotspot locations. Question, when Mauna Kea was glaciated in the Ice Age, were there explosive eruptions then? That's a fun question. So Mauna Kea is, of the 5 volcanoes on the Big Island, it sits here. Kohala, which sits to at the north end of the island, is completely extinct. Volcanoes not likely to erupt there anytime soon. You can see some of the big gullies eroded into it. But Mauna Kea we've classified sort of as a potentially active volcano. It's sort of in its last gasps, if you will. You can see that the surface of this huge shield volcano, which is the tallest mountain on Earth technically, is just dotted with these reddish cinder cones that just kind of sit everywhere. And so there's these big cinder cones that sit all over its summit. And none of these cinder cones seem to have any signs that there was ice above them when they erupted. So while this volcano was covered with a small glacier, I don't know what the extent was, during the last ice age, as far as I know, there's no evidence of subglacial eruptions on Mauna Kea. But it's a great question and one I've never actually thought about before. I don't think any of them are. You know, what we'd expect to see is something like we see in Iceland with fragmented rock, hyaloclastite, these landforms we call tuyas, and pretty much everything on Mauna Kea's flank are these little cinder cones. Well, I mean, they're small compared to Mauna Kea itself. But these are all clearly not related to, there's no water involved with these forming. There's no substantial amounts of ice. These seem to have formed in the absence of any water. Really good question, though. Thank you for that question. Next question. Why does Hawaii have more shield volcanoes than Iceland? I don't know if that's true either. And it sort of depends on the scale you look at it, right? So Hawaii is made out of, the Big Island's made out of these 5 big shield volcanoes. But on those shield volcanoes, for example, if we go to Kilauea, let me take off some of these lines here, and go down the Middle East Rift Zone, Mauna Ulu is considered another shield volcano on its flank. So it sort of depends on how you count shield volcanoes, but there's plenty in Iceland as well. So I'm not sure, I don't have a number for you. It'd be a fun little exercise for someone to count shield volcanoes on Hawaii and Iceland and see what the numbers bear out to be. But I wouldn't say that Hawaii has more. In fact, I wouldn't be surprised if Iceland has more. Iceland's a bigger island. I wouldn't be surprised if it has more than whatever the Big Island has. Someone asked, how is a caldera formed? That's kind of a long answer, but the basic idea of a caldera is that there's collapse. So if we go to, let's go to Mauna Loa's summit. Mauna Loa's summit, you can see, let's see if I can get it in view nicely for you here, this sort of oval-shaped caldera. So a crater is formed by stuff being thrown out. So you'll get a pit if stuff is thrown out. So these big cinder cones on Mauna Kea exist because little gassy pieces of lava were thrown out onto the surface and built up a cone. So this is a crater proper. But a caldera is different. It's formed by wholesale collapse of the surface downwards. And usually with these types of volcanoes, it can happen when magma, which is underneath the summit region, leaves or moves into some other portion of the rift zone. And we saw that in 2018 at Kilauea. The magma that had been stored underneath it started moving down the East Rift Zone, bypassed Pu'uo'o, and started erupting in earnest in that historic eruption in 2018 down here in the lower East Rift Zone. And what that caused then was that caused the landscape of Kilauea to change. Let me see if I can show you this. So to kind of take a little mental image there, and what we'll do is change the date, and let's look at Kilauea in early 2018. Let's see if we've got a good image here. Here we go. Let's see if that, there we go. So here's 2017, December 2017. Kilauea was a fairly simple caldera that had a smaller sort of centralized pit, Halima'uma'u, over here. And this is sort of what it looked like. And there's even, I think on this view, there's even a little bit of, maybe a little bit of glow in there. Yeah, so there's a little lava lake right there at the summits. So take a good look at Kilauea, as many people remember it, because it looked like this for a long time. Okay, and then I'll bump this to what it looks like today. Let me get rid of my little icon here, because you don't need that. Ready? So I don't know if you saw it there, but it changed pretty dramatically. In fact, here's an even closer time sequence. So here's December 2017. If we go over here to a year later, notice the difference. See all the cracks that formed here? Actually, the Kilauea's caldera deepened and as it partially collapsed during that period. So you can see, all these fractures over here. This is why they've had to vacate the Hawaii Volcano Observatory and the Jagger Museum that's on the rim. Is there's these big cracks that started opening up over here. So they've actually demolished, or they're in the process of demolishing that building. So anyway, caldera formation. Which place has more volcanoes? I guess Iceland or Hawaii. In terms of large active volcanoes, I think Iceland does. I mean, if you look at the Big Island, we really just have 4 major volcanoes that are either active or potentially active. So we expect eruptions from Kilauea. We expect more from Mauna Loa. We probably would get some more from Hualalai because it had eruptions 200 years ago. You can see these flows down to the ocean by the airport. Mauna Kea may be done, but we're not ready to totally put all the nails in its coffin just yet. So I would say Iceland by far has more volcanoes. There's like 30, something like that. Couple more questions, and we'll get to the ones that you guys have been submitting. And Amanda Jo, you can probably send those already if you haven't already, or send them now. Do all the Hawaiian Islands still have active volcanoes, or is there any that will no longer erupt again? So pretty much it's just the Big Island that's still considered active. There is a tiny, tiny, tiny chance that Haleakala on Maui, which is the youngest volcano on Maui, you can still see it kind of looks a little bit like a Mauna Kea version with the cinder cones kind of capping its top here. There is a chance this could erupt again. I think the last eruption there was like, I can't remember. Was it like 6,000 years ago? It's been quite a while. But all the other volcanoes, there's a volcano here on Maui. Not a currently active one, but this is what formed this area here. All the other Hawaiian Islands are volcanically not active, or they're extinct, if you want to use that word. Someone asked why Kilauea is so active. It is the primary pathway for the hotspot, which we think sits kind of under this region. So it and Mauna Loa are most directly linked to this continual supply of hot rock and magma called the hotspot. Will Svartsengi, which is in Iceland, and Kilauea keep erupting for a long time now? The better chance is Kilauea keeps us up. Kilauea has been erupting not nonstop, but quite often, and definitely within human lifetimes since, I don't know, since the ancient Hawaiians were there, whatever, like for centuries, if not longer. The Svartsengi thing, remember we just saw that eruption on the Reykjanes just popped up for the first time in 800 years. And so if I had to bet which one of those two would be the most consistent moving forward, I guess I would give a slight edge to Kilauea, with the caveat that when we look at the Reykjanes' history, it can erupt on and off for centuries as well. So it might be a dead tie between those two. And then the last question from the email chain, I know Hawaii has over 100 islands. Are they connected under the water, but some of the area eroded away? Or are they all individual islands like an archipelago? So there are individual volcanoes or former volcanoes, and in some instances, those volcanoes, the lava and material that they erupt has merged the land together to form one contiguous island, like we see here on Maui. The Big Island is nothing more than 1, 2, 3, 4, 5 volcanoes that are, 3 or 4 of which are still quite young, and because they've erupted recently, that's kept that area high topographically and is merged into one big island. But they're all there for the same reason, the hotspot, and you can chase these from the Hawaiian Islands off to the northwest where they're submerged. There's no islands out here for the most part. These are called seamounts, but you can see where they used to be, right? You can see the trail of volcanoes or former volcanoes and islands that kind of goes out away from that. So great questions there. Okay, so what I want to do next is see the first sheet of questions from you folks on the live stream is coming in from Amanda Jo. So from Mantlewind, how did this Nepal crater form? Is it a caldera? Great question. And I'm trying to brush up as best I can on some of these things as well. The best answer is I don't know. We have a couple different features here in the East Rift Zone, so let's go over these together. So we have Mauna Ulu, which has a summit crater, but is clearly a shield volcano where lava flowed out in multiple directions. And of course, we were able to witness that from 1969 to 1974. That was the birth of that volcano. Similarly, to some degree, Pu'uo'o started erupting in 83 and went on for 35 years. So I would call this also a shield volcano with a summit crater. I don't know if it's quite big enough to be a caldera. Calderas need to be usually like at least a kilometer across. And then we have Nepal crater, Makopuihi crater. And these are pretty big. They might be calderas formed by collapse. I think that's an excellent hypothesis, but I'm not sure. And then there's these smaller ones in here, and I do know what these are, and I don't know the names of all of these off the top of my head. We could look at the reference map, but there's a nice one right here by the road when you drive down the Chain of Craters Road, this one right here. And these are pit craters. So these are places where there's been collapse beneath in the East Rift Zone as magma's moved away from the East Rift Zone. There's been wholesale collapse downward that's created some of these pits here. But because they're not quite big enough to be called a caldera, it's a similar formation, but they're given a slightly different name. So Nepal is pretty big across. I think we could measure it real quick, can't we, right? It's almost a kilometer across that way and running this way 1.1. So it might be kind of on the cusp. Usually it's around a mile or so to be considered a caldera. But again, it's just a name. It's still the same process. So I don't know for sure, but my guess is Nepal crater is a subsidence or collapse feature. It definitely doesn't show any sign. It's not a shield, and it doesn't show signs of throwing stuff out of that pit. So that's of course, it's been filled in with multiple flows of lava over the last 100 years as well. So really good question there. Learning together. So I'll see if I can dig through that a little bit. Or if we can get a USGS person on, we could ask them. Scott Russell wants to know, will the main volcano erupt and how big? Well, I'm assuming you're talking about Kilauea's summit. This eruption we're seeing in the Middle East Rift Zone is part of the main volcano. It's just along its flank. So these are these flank, or in this case, a rift eruption. But sometimes those can be more dominant. I mean, 35 years, this was the main player in Kilauea's activity. It was way over here. How big in terms of lava? Well, we've seen, 2018, we saw huge amounts of lava come out in this area. So it could be big in terms of lava output, but it probably won't be big in terms of explosivity. There's no reason to think that these eruptions are going to turn explosive based on what we've seen in the past here. From Vincent V, where is the main source of the lava? Some from the summit and a deeper source. Well, we think if we go back to the little cross section there, the idea is it's being fed here, but it's being held in this shallow reservoir, and then it gets pushed into the East Rift Zone. Maybe the conduits that take it to the summit are no longer available. Maybe there's rubble that's fallen in there. Who knows what? But they actually are erupting out the East Rift Zone here. So, it is coming from the deeper source, but then it doesn't just move through this shallow source and then out to the East Rift Zone. It actually there's residence time here, and they're able to tell that by looking at the crystals. The crystals sort of preserve and illustrate the cooling history and the ascent of the magma through the system. Vincent has a couple of questions here. Is there a deeper supply that is supplying this eruption? The tilt meters have leveled off. Yeah, so it depends on which tilt meter you're looking at. There's summit tilt meters. There's some out in the rift zone itself. And then his other question is, the main summit supplying any lava to the East Rift Zone from the crater like the 2018 eruption? Yeah, these are the kinds of questions I'd like to ask too. If we can get a USGS Hawaii Volcano Observatory person on here, I'd like to know why in 2018 the magma left the summit area, completely evacuated it, started moving into the East Rift Zone, bypassed all these former vents in the Middle East Rift Zone and went all the way down into the lower East Rift Zone before erupting. And it seems like the least or a poorly efficient way for the magma to travel. And yet we know the magma generally will follow the most efficient way. So what was different then? Why didn't it just go into Pu'u'o? Why did it actually, pull more magma out of Pu'u'o and go further down? From Dan Cooper, is the geochemistry of the lava from Kilauea similar to the Iceland eruptions, given that they both emanate from hotspots? I'm not a geochemist. Broadly, I'd say yes, but I'm sure looking at the details and the trace elements in that geochemistry, you would see some differences. Fundamentally, the rock type, if I handed you two rocks and said which one's from Iceland and which one's from Hawaii, I wouldn't even know. Like, there'd be no way to tell them apart. The geochemistry probably does have some differences. I just don't know those off the top of my head. But again, a great question. From T. Zaris, it would be interesting if this is going to reestablish the lava tunnel network back to having eruptions at Pu'u'o. Yeah, absolutely. And that was one of my thoughts too initially. Once we started seeing the Middle East Rift Zone becoming active again. Was it going to bring it back to Pu'u'o, or was it going to stay in this zone? Because remember, before 1983, this is where the action was, right? It was here, and then it pushed further east, erupted here for a long time. Then that's as far. Then in 2018, the Middle East Rift Zone shut down completely, but then it. Later in that year, in the April or May, it actually moved all the way down the East Rift Zone and started erupting down here in Leilani Estates at the the far east end of the island. It'll be fascinating to see if that kind of plays out. From Tennessee Greg, why has the lava erupted from different areas there if it's over a stationary hotspot? I think it's all the plumbing system. That it's a complicated, these cross sections are super simplified. It undoubtedly looks nothing like this, but the big concepts of a plume, an ascent of material up, and what this isn't showing also is like the three-dimensional. I mean, it's trying to be three-dimensional, but if I could modify this, the plume's actually over here, down towards the bottom left corner, based on seismic tomography. It's coming up underneath Pahala. That's where those deep earthquakes are, and then there's some sort of channel conduit that takes some of it to Mauna Loa when it's erupting, and it has a summit magma chamber too that's, we think, refilling and recharging slowly, but then some of it's being taken over here to Kilauea. They're not even sure that there might be a connection between Mauna Loa and Kilauea, like one erupts, one shuts down. There's a little bit of interplay between those two. I think that's been studied to some degree, but it's very complicated and complex, and that's the thing. So Greg, it's an obvious and very good question. The hotspot is stationary. The plate is moving, but very slowly. So why, even in our given lifetime, Hawaii's and the plate is pretty much in the same spot, yet we've seen eruptions from this same hotspot in our lifetimes from Mauna Loa's summit, Mauna Loa's northeast rift zone. We've seen eruptions in the southwest rift zone of Kilauea, the summit of Kilauea, the upper east rift zone, the middle east rift zone, and the lower east rift zone. So that's 6, 7 different areas. And I think, as the magma plume comes up at depth, everything above it is very close. So just a tiny little, if it follows one crack versus another, that manifests itself as being in a totally different location. But if you actually trace those down to these deeper, where these deep plumes are, it's not much of a angle between the two, if that makes sense. I wish I had better answers. You guys are stumping me. It's great. Scott Russell, what type of volcano is this volcano? Not sure when you asked the question. Right now we have fissure eruptions on the east rift zone of Kilauea. Kilauea fundamentally is a big, monstrous shield volcano, but it can produce, as it erupts, it can have fissure eruptions, which are primarily along its rift zones, its southwest and east rift zone flanks. It can also have rift zone eruptions that start out as fissures but evolve over time into centralized shields along the flank. It could have, I don't know if there's a couple little cinder cones on here, like this little hill right here is an older cinder cone. This is Pu'uhuluhulu. And so you got this flow from Mauna Ulu kind of partially covering it. So you can also get cinder cones developing along its flank. And so the problem is the labels we use. This is kind of the issue with the last little 101 video I put out, is like labels with volcanoes. Like big volcanoes tend to be complex and have multiple vents and multiple styles of eruptions, and therefore are not easily, defined by one specific label. Susie Ryder 55, with lava supply coming from the caldera, is there likelihood of collapse like in 2018? I don't think it's feeding nearly enough of the lava out of the summit reservoir for that to happen just yet. What we would need to see is probably a greater output of lava in the eruption area, or movement of the magma either to the west or to the east, breaking open more fractures. So we'd need to get a lot more of this magma underneath the summit reservoir into the East Rift Zone than we currently have right now in order for more of the summit caldera to collapse. But again, that's a good thought coming from you. Okay, one more question, one more sheet of questions, and I think this will be good for me, Amanda, Joe. Let me check the live chat real quick. Oh, thank you, New Phase 4T. Thank you for your kind generosity from Kilauea. Great. Helicopters going all morning, donating to the Refill Lake Bonneville cause. Yeah, it's tough sledding on that front. All right, Leon Munoz, is there a specific reason why ground deformation is measured linearly in Iceland and angularly in Hawaii? No, so I think what the essence of the question is the USGS uses both. There's GPS stations. I just didn't show you those, but I could to show you more like what we've been tracking in Iceland. So we could look at, for example, a GPS station and show here is the up and down movement of this station. Let's find one. Let's see. Yeah, let's use this one. This one's nice and close. So there you go. There you got one that's got some good stuff there. So there's the east-west component of motion. Here's the north-south component of motion, and then the up and down. They use both. The USGS uses both GPS, tilt meters. They also use satellite and INSAR data, just like we've seen in Iceland as well, those kind of rainbow-colored graphics. To my knowledge, Iceland doesn't use the tilt meters. They mainly use the GPS. I don't know exactly why. That would be a question for the Met Office. They're capturing the same data, the up and down movement, just a little bit differently. So, but very good question. You guys always ask good questions. I know I keep saying that. From Marion, hope you're doing well, Marion. Has it been determined whether or not the Kilauea plumbing system is connected to Mauna Loa plumbing system, since they both erupted at the same time last year or the year before? Yeah, there's definitely some sort of connection, but I'm trying to remember. There was a paper written, and so I'll probably get it all wrong, so please don't quote me. There is a connection between the two. One of the interesting things about the Kilauea Mauna Loa dynamic is that Mauna Loa is partially supported, and well, they share this border, right? The Kilauea is up against Mauna Loa on the southeast side, and that's why you have a rift zone from the southwest side of Mauna Loa's summit, and then one that comes off the northeast side, but not one that comes down this way, because it's actually got the support of Kilauea. Sometimes these big shield volcanoes in Hawaii have 3 radial rift zones, but Mauna Loa just has 2. Kilauea similarly just has 2, the southwest rift zone, the east rift zone. There should be one. If this was a volcano all by itself, there probably would be one going off to the northwest, but it's buttressed against Mauna Loa. And so the idea here is when Mauna Loa, if I remember the paper right, and again, I might get this all wrong, but when Mauna Loa is very active and there's magma there, and its rift zone opens up to allow the magma to come through. So everything kind of moves open, like in a northwest southeast direction. Sometimes that movement towards Kilauea can impinge on Kilauea's plumbing system and maybe not cause it to stop erupting completely, but possibly reduce its output. And I hope I'm getting that right. And I can't even remember where the paper is, but I did read that sometime in the last 3 or 4 years. So to answer your question, Marion, yes, they are connected. I don't think we've ever seen a historic eruption where they're both erupting like kind of like full tilt, like, high volume eruptions at both locations. So that's something that's a little bit different. VIBC Outdoorsman, could this type of rupture eventually lead to the Pacific plate breaking to form 2 new plates? No, I don't think so. I don't know enough about kind of like the how robust these plates are. But what we have is a clear track record up the Hawaiian Emperor Seamount chain, all the way up here into the North Pacific, that goes back, I think, 65-ish or so, 70 million years ago, that shows nothing like that. No large fractures developing on the seafloor, nothing other than a chain of volcanic islands or old volcanoes submerged now from that hotspot. So, yeah. And remember, these are weak, right? These islands are sitting on a very weak base, and that's why there's frequent collapses, either fast or slow, along their flanks. They're getting pounded by the ocean. There's a heavy rainfall there. As they move off of the hotspots, they start to cool. The rocks contract. They go through a series of earthquakes. As they move off the hotspot, everything thermally contracts as well. And so that's why the islands get smaller and eventually kind of fade into, submarine features as we move up the chain there. Stuart wants to know why this island is bigger than the others, because it's sitting on the hotspot. So the magma plume is right underneath this southeast part of the big island, and as it continues to pump out vast quantities of magma that erupts at the surface as lava, that builds the island bigger and bigger and bigger. These islands are smaller because they've moved off the hotspot and they're being eroded, and they're sinking, literally sinking. If you look at the elevations of these islands, Kauai maybe has an elevation of like highest points like maybe 5,000 feet above sea level. Maui's high elevation on Haleakala is about 10,000 feet. Then you come over to the Big Island, and both of these are over 13,000 feet tall. But they will eventually move off the hotspot, become inactive, sink because they're cooling and they're losing some of that buoyancy from the heat. And let's see, last question, VIBC Outdoorsman also asks one more. Has anyone done any lithospheric measurements, depth of or in cross-section, out from perpendicular to the rift zones? Not sure I followed that question. So rift zones are here, perpendicular would be this way. Lithospheric measurements, like how deep, like how thick the crust is? Not quite sure. Probably, yeah. Sorry, I couldn't follow you on that one. Cool stuff. Let's see. I think I got through quite a bit of questions there. 2 pages from Amanda Jo, and then the original set of questions that were sent yesterday. So, she sent me one more thing. Let me grab that real quick. She says there's some new photos from the USGS. So let's wrap this up, team, by looking at one more set of photos that just came out from the USGS. And thank you, Amanda Jo, for sending those. And let's look at these together for the first time. Okay, so they've got their the chronology photos up. So these are some new photos from today. Let's get the size good for you folks. So caption here says, last night, September 18th, glow from the eruption was visible from Chain of Craters Row, which, they reopened that yesterday. Oh, interesting. Okay, I didn't know if it was still closed. So Now the Chain of Craters Road is open. You still, I'm sure this is true, you can't hike in from the Mount Ulu trailhead, I'm sure is closed. But at least from the Chain of Craters Road, you can see the glow, and you can still access all the wonderful sites on the Chain of Craters Road. So again, that roadway sits here. So here's the road that goes around Kilauea's summit, and then here's Chain of Craters Road right here. If this is the part that I think is closed, that trailhead, but you can continue down Chain of Craters Road. It's a fantastic drive. I mean, usually when I take people on tours there, we spend a whole day stopping in pullouts, looking at stuff on Chain of Craters Road, and then you end up down here along the coastline where these lava flows covered the roadway in the 80s and 90s. So great. Okay, back to the pictures. Sorry, a little bit distracted. Good stuff though. September 19th overflight. Caption reads, the 150-meter long, nearly 500-foot fissure erupting west of Nepal crater within the park began erupting yesterday around 3:15. So this is the one above the rim, and this is the one creating the lava fall, if you will. It's part of an eruptive sequence that began in this area the night of September 15th. That was Sunday. Overnight, this fissure fed a lava flow that cascaded into the crater via a channel more than 50 meters wide. That's a wide channel. That's a river of lava that is wide, is half the size of a football field. Pretty impressive. Let's see. Let's read the caption, then we'll make this one bigger. Overflight this morning, geologists observed the fissure west of Nepal crater generating a lava flow that travels northeast before cascading into the crater. This is looking south from the north side of the eruption. So let's check this one out real quick here, folks. So here's our fissure event here. Here's this very wide channel. You can see that smooth lava river here. And then there's the rim of the crater right there where the trees end, and you can see the blue gas. So there's the lip of the lava falls. There's the Nepal crater sitting down here. So there's where the fissure sits. This photo here says kind of the same thing, just a different viewpoint. So here we are looking at the lava flow a little bit more from the northwest, I think, and then the lava channel flowing a short distance and then flowing right over the rim there, just cascading straight down. So yeah, so they put a few more photos up here. They might get some other photos or video up too as time goes forward. Someone just asked, will they be putting a live camera up of the eruption? If I don't know. I mean, I don't work for the USGS, but in the past, if they can, they will. I wonder too if there's some difficulty getting the signal out to have like a continuous live feed. That part of the park, you don't often get good cell service, and so I don't know what the telemetry is like to get that into that part of the park. So that may be a difficulty there. But I imagine they will if they can. So if they can get their camera, right now this is the best we have, is this S2 camera, a portable camera that they just set up more or less on the opposite rim of Nepal crater looking back towards the eruption site. They also have to think of things like where the winds fluctuate and not wanting the camera to be downwind of the gas plume and tephra, little bits of ash or glass that might be erupting as well. So those are some things to consider. So yeah, not sure, but I think they're doing their best. So yeah, let's see. I think that's probably about it, friends. Any other questions? Yeah, so they've got this one, which runs every hour, takes a still shot. This one's, I think someone says, refreshes every 15 minutes. I know that's not awesome. This is nothing at all like the eye candy reality show that was the eruptions on the Reykjanes in Iceland. I think there's some reasons for that, but I don't think it's for lack of trying. I don't think they're trying to it's not duplicitous by any means. It's a big area, and it's really remote. It's rainforest. It's rugged vegetation. It's a national park. It's a huge national park, and there's only a road or two into that whole area. I mean, this whole region here, the park kind of covers everything from Highway 19, this yellow line here, The park boundary kind of cuts over to Pu'uo'o. So it's pretty much everything from here over to here, around the crater, and down the rift zone, with this highway being just slightly outside the park. So all of this swath of terrain, the only way to access it, there's one road. There's that road and the little road around the crater, and that's it. Everything else is hiking trails, and even then there's not a lot of hiking trails. There is one other road I forgot about that. Is it the Helena Pali Road? There's one road that cuts off of this one somewhere in here. That's it right there. Yeah, there's this little road here that comes down this way. Anyway, the point is there's not a lot of roads into the area, and certainly out into this region out here. So, yeah, hopefully this was a good live stream. Did we have fun? I had fun. Did we learn? I learned I need to learn some things about some of these craters, and I have some questions to ask. I wrote a few of those down, and I'm going to reach out to the few contacts I have at the USGS and see if we can get someone on. I think that would be fun to talk about some of these questions we have about Kilauea with someone that studies it, that might be an expert. In the meantime, we'll just keep watching and see how these things go. I'll be gone this weekend out of town. But I'll have some other videos in the hopper for you. And when I circle back and I'm back in the office next week, if there's anything going on at Kilauea, then I will certainly do my best to inform you, and we'll all learn together. It's a fun time to be watching volcanoes. It was nice, and I do thank the volcano gods that the Iceland eruptive activity ended just as this began, because I don't think I have the bandwidth to cover two very active eruptions at once, in addition to teaching classes and some of the other things. So thank you, Iceland, for pausing your volcanic activity for the interim. I might do another Iceland update sometime in the next week or two. I did get an email from Bruce Garner, and he's projected out based on the uplift rate around the power plant at that GPS station. He's looking at, like, again, his modeling is just based on what's happening and just extrapolating that outward. He, I think in his email, said it looks like maybe the mid-December to around Christmas time is what possibly we could look for the next eruption there. Again, that's a long ways out, lots of variables, lots of things that can change. So we've got, potentially, 2.5 to 3 months before maybe we're looking at another eruption there. So good stuff. Great work, team. We did it. Well done. If you're in Europe and you're still awake, thanks for joining us, but please go to bed and get your rest. Thank you to Susan and Amanda Jo for being moderators here today. Awesome work as always. You can support the channel a number of ways. There is the little thanks button below the your viewer screen there, or here on YouTube. And under every video description, I have a couple links as well where you can donate to the channel, help us get these videos out. It's a labor of love, but every little bit does help and count. So great work, team. Well done. And I will see you soon. Take care, and thank you.